All right, let's get started. Good morning, everybody. Welcome to Chem 1211 with your host, me, Dr. White. What I like to do is start out with some important public service announcements from me, your host. The first one is get your flu shot. I got mine yesterday. I would have gotten it last week, but they ran out of the super flu shots or the high potency. For those of you who haven't figured out, I am over 65. But anyways, get it. About 3 or 4 years ago, I wasn't getting flu shots. I caught the flu. It got really bad. And at one point, I was in my doctor's office. I was really sick. You know how they put that thing on your finger to get your oxygen level? And he took it and he said, I'm going to try some treatment right now in the office for your lungs. If it doesn't work, I'm sending you to the emergency room of a hospital now. Luckily it worked, but I learned my lesson. Get your flu shot. Whatever it costs, and they aren't that expensive. Mine is paid by uh, Medicare, but again, I'm over 65. But get your flu shot. All right, two other public service announcements, actually maybe even three. One, don't forget to hand in a lab that's due this Thursday. Labs are easy points. You don't want to lose them. Your grade's based on points. All right, that's one. Next public service announcement. All right, this Thursday, and I'll be putting out an email later today with this coming Thursday, I will be going through practice problems for chapter 10. There are two parts. Do them before I do. All right, and finally, the last one, and that you may not like to hear, but I'll be honest with you. Test one always has the highest average of the semester, always. And trust me, I've been teaching this course more than once, twice, well, enough times. And I teach a similar one at Elgin Community College. Test two usually is the lowest average. Not always, but most of the time. But last semester, and a couple semesters before, I had a 1211 that it wasn't. However, you got to keep up. You got to do the, well, you don't have to, but if you want to get a good grade, you have to do the practice problems. Because as I mentioned a couple of times, who's the greatest of all sports stars, one of the greatest in Chicagoland history? That's Michael Jordan. And back in the mid 1990s, I don't know if you remember that. I hate to ask what year some of you were born. But anyways, uh, Michael Jordan was the best of the best of the best, the very best in the NBA. And you'd always hear in the news, TV, sports, or reading the newspaper, Michael Jordan, always the first on the practice court and the last one off. Why did he have to practice that much if he was the best? Because it kept him the best. And that's the same thing in chemistry, no different. No, you're not going to go on a basketball court, but do the practice problems. That's why I created them. All right, before I start, any questions? Check the chat. By the way, Friday, Saturday, and Sunday, Dr. White did battle with Mother Nature. I pruned my, what time is the lab due? I'll have to check, either 5 p.m. or 8 p.m., one of those two. It's not 9 a.m. If we were at COD, it would be due by the time I walk out the lab at the end of the lab in the building. You know, if we had labs, say on Thursdays, we'd have labs, say from 9 to 11:50. And when I walk out the building, I better have your lab. But since we're not, I give you some extra time. But anyways, I did a battle with Mother Nature, about tune of almost 7 hours. The lab is due this Thursday, the one we did last Thursday, and it's due by the end of the day. If you're a half hour late, I won't take off points. But if you're a couple days late, I will, because this keeps me right now I have about 40 labs per week between this course and another I have to grade, and I don't want them piling up because that's not good, not fun. All right, any other questions? Anyways, really do the practice problems. We'll do chapter 10 this Thursday. All right, thumbs up, people. You see chapter 6 on the screen? Thank you. Or nod your head, people. All right. Little review. Remember, formula mass, or Dr. White calls it molecular weight, is the sum of all atomic weights of the atoms in a formula. An example, water, you'd have 2 hydrogen, 1 oxygen. Hold on 1 second. Something I didn't open up. All right, everybody should see a periodic table. Good. Thank you. Thanks to all my thumbs up people. Zoom, and I had a lot of trouble yesterday, and I stopped doing the thumbs up, and that was a mistake. My other class, so I'll keep on doing it. Please be patient. All right, just a little reminder. Here's a periodic table. The number underneath the element is the atomic weight of that element. On test number 2 and 3 and 4 and the final, it will say, please use all atomic weights, the 3 significant figures. You know significant figures now. And if we look at the periodic table, let me blow it up a little more. If we look at hydrogen, what is that, the 3 significant figures? I'll give you 3 seconds, go. Time's up, I gave you some bonus points. 1.01, keep the 1, keep the 0, keep the 0. Use the 8 to round off, is that 5 or higher? Yes. Drop it and the number in front increase by 1. That's why it's 101. Let's look at carbon. What's the atomic weight of carbon, the 3 significant figures? Your turn. I'll give you 5 seconds. Time's up. Put down your computer. No, anyways. Keep the 1. Keep the 2. Keep the 0. That's significance after decimal. Use the 1 to round off. Is that 4 or less? Yes, you drop that and the other. And the 3 significant figures, the atomic weight of carbon is 12.0. Let me move it up so you can see it better. Do oxygen. What is oxygen to 3 significant figures? And the answer is 16.0. How did you get that? Keep the 1, keep the 5. Remember, we're doing 3 significant figures. Keep the 0.9. Use the next 9 to use to round off. Is that 4 or less or 5 or higher? 5 or higher, I hope you all got it. So that and that you drop, and you increase this by 1. That becomes 1.0. Therefore, the correct answer, oxygen, is 16.0 for the atomic weight. And you can go through and look at the, oh, let's do one more. Ooh, let's do bromine. Round that off to 3 significant figures. And the answer is, I bet you're holding your breath, probably not. Look out, it's awful humor Tuesday we're slipping into, but it's 79.9. And if we look at this, keep the 7, keep the 9, keep the 9. Those are 3 significant figures. Use the 0 to round off. Is that 4 or less? Yep. So drop that in a 4 and it's 79.9. And that's how you do significant figures. So let's go back. And hopefully you all see practice time on there. Thank you. And I'll let you try one on your own. And a lot of times I'll do like always. What's the molecular weight of ammonia? Hydrogen, and I'll give this to you for today. On the test, I won't. Dr. White knows these by heart because I use them enough. What would be the molecular weight of ammonia? Go. If you don't have a calculator and you can't add in your head, just set it up. Sad thing I heard a couple of years ago, and I assume it's true, that in grade school they no longer teach multiplication addition tables because students have calculators. What happens if you have to add or subtract or multiply and divide and you don't have a calculator? I guess you got your cell phone. Still, I'm against that. And when you're done, look up and smile or give me a thumbs up or, ooh, give me the high sign. Most of you don't know what I just did. I just did a generation gap on you. Watch on YouTube, our gang. High sign. All right, let's do it. Now, the molecular weight is the sum of all atomic weights. Therefore, I have 3 hydrogens and 1 nitrogen. Each hydrogen is 1.01. Each nitrogen, which there's only 1 of, is 14.0. Do the multiplication. These are exact numbers. Because you can't have half an atom. Show me how to do half an atom and I'll be rich. So will you. Now you add these up, but I'm not done. This is not the answer. Why? Because when you do addition, you have the same number of significant figures past the decimal point as the number that has the fewest significant figures past the decimal point. This has 2. This has 1. Which is the number that is the lowest? Time's up. Hopefully you pick 1. Therefore, how do you round this off to 1 past the decimal? This you keep. This you use to round off. This is nice. I use those squiggly lines to let you know. Thank you, Dr. White. You're welcome. And is this 4 or less or 5 or higher? So I drop that. And the correct answer for what's the molecular weight of ammonia using atomic weights of 3 significant figures is 17.0. Oh, let's do another one. Sodium hydroxide, also known as lye. How many of you ever heard of lye soap? This is used to make that. The settlers, our ancestors, used to treat animal fat with lye and water and make the soap. I teach that in organic chemistry. I actually worked for a company that made that. And sodium is 23.0, oxygen is 16.0, and hydrogen is 1.01. And what would be the molecular weight of sodium hydroxide? Ooh, 3 points each. Say sometime in the future, I ask you questions that are associated to points. That might be one of them. By the way, Dr. White knows this by heart because he uses a lot in industry. And for those who came in late after I did it, good morning to you all. All right, let's do it. What's the molecular weight of sodium hydroxide, NaOH? It's the sum of all atomic weights. And I give them to you, so let's add them up. Because there's one sodium, one oxygen, one hydrogen. By the way, if I ever make a mistake adding in my head, let me know, please. Now, is this the final answer? And the answer is no, because when you do an addition, which this is, you have the same number of significant figures past or to the right of the decimal as the numbers you're adding that has the fewest. This has one past the decimal. This has one past the decimal. By the way, that's a 0. This has, oh, look, 2. Now you have to use your real hard math skills. What's the lowest number? Times up, 1. So how do you round this off to 1 past the decimal? You keep the 0, use the 1 to round off. Is that 4 or less? And the answer is yes. So I'm going to drop that. So the correct answer for this problem is this, 40.0. If you don't do this correctly, I take off a point, because on my test, I will say 2 things for test 2 under your name. Please use proper significant figures for all calculated answers, and please use 3 significant figures for all atomic weights. If you don't, you lose points, which is not a good thing. Now, I'm going to speed through these next slides because I've already done it. We talked about the mole. You should know the mole is the counting unit used by chemists. One definition is 1 mole is 6.02 times 10 to the 23rd. I showed you that if you have one thing equal to another, you can have 2 ratios. By the way, my birthday is coming up the end of December, and all I want for a birthday present, there's still time to save, is 1 mole of pennies. It's just pennies. It's 100 million piles, and each one would have $1 billion in pennies, which would be 100 million billion. I think that's more money that's on the planet right now, maybe. But it's just a mole of pennies. Now you know a mole is a large number. When you look at Avogadro's number, 6.02. And I showed you how 1 mole of an element equals Avogadro numbers of atoms. 1 mole of a molecule of a compound equals Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules. And because of that, you can have 2 ratios. And we did some practice time. Ooh, let's do some more. And the question is, how many moles are in, and I could have put up here, moles NaOH. I didn't because I wasn't sure what chemical I was going to put down. I make these problems on the fly. Dr. White's that good. And why don't you try this one yourself? And remember, 1 mole of a compound equals Avogadro's number. I will give you that in important information in test number 2. I'll write it down here. It's your time to have fun. By the way, if I say fun enough times, you might believe me. It's working. I see people smiling even. Remember, this is a time to use your good buddy, your good friend, unit analysis. You didn't think I'd go to a whole class without using that, did you? No way. Did anybody happen to go to YouTube and look up fireworks like New Year's Eve or 4th of July so you could see electrons moving from shell to shell? There's some good ones on YouTube, but it's not the same as being there, feeling your body vibrated by the explosions of the fireworks. If you don't have your calculator, just set it up. Because don't forget, on a test, set things up, show your work so you can get partial credit in case you make a mistake. And when you're done, give me a thumbs up. For those of you who don't have your video on or don't have video, I think you can get to the emoji, if that's how you pronounce emoji, button at the bottom or wherever on your Zoom lecture picture. I was reviewing this morning where we are, and we're in a good place, which is why I'm going through and doing this again, because this is probably one of the tougher parts, getting your hands on, understanding what's going on. And it's important you understand how to use unit analysis, because you'll be using it for other things too, because your good buddy, your good friend, unit analysis. I love that whistle siren. All right, let's do it. When you look at a word problem, first thing you should do is ask, what am I being asked to find? Moles of sodium hydroxide. What am I given? And once you write these down, you never have to look at this again, other than this thing where you'll be given if you didn't memorize it. The past, I'd make students memorize it. Now I don't. Because about a year and a half ago, I came to the realization, should I be testing a person's knowledge of chemistry, or their memory and their knowledge of chemistry. And I came to the conclusion, this is not a memory class, this is a chemistry class. So that's why I give you this information. All right, now, how do you proceed? Use your good buddy, your good friend, unit analysis. This is the only number I have to start with. For those who don't have your magnifying glass out, that's molecules. And what do I want my final answer to be units wise? And we figured that out already. So I'll put that here. Now, if I had a magic ratio, no, it's chemistry, that I can convert where I'm starting to where I want to get to, now you use the unit analysis. Whatever you're trying to get to goes on top of this ratio, the units. Whatever you're trying to get rid of, go underneath. That's all you got to remember for unit analysis. But now you got to find what numbers go here. And where do we do that? We look up here and notice, well, first, what do I want on top? Moles, NaOH. What do I want underneath? Molecules, NaOH. And where do I get that number, these numbers? Notice 1 mole equals Avogadro's number. And it's 10 to the 23rd in case you can't see it. And before I pick up my calculator, I'm going to do the following. Check my units. Now, normally you don't have to do this, but let me do it the long way just to show you. Now, let me remind you, anything divided by itself equals the number 1, which means it's gone. And if I do this multiplication, I'd have molecules of sodium hydroxide times moles divided by molecules of sodium hydroxide. This cancels out, and I'm left with that. Now, let me show you if you set this ratio up backwards, or upside down, not backwards. You have molecules, NaOH, times molecules, NaOH, divided by moles, NaOH. And let me remind you, and how do you know? Because what's the final units of your answers? Molecules of NaOH times molecules divided by sodium hydroxide, moles of sodium hydroxide. That's not what I want. So once again, checking your units using unit analysis helps you determine this is wrong, no, and this is correct. If I can spell it right. And that's how you use unit analysis. Now I can go to my calculator. And hopefully everybody sees my spreadsheet now. Do you see the spreadsheet? Thank you. And now I'll put the numbers in, and for you, do it in your calculator. I'm going to take that and divide it by Avogadro's number, 6.02 times 10 to the 23rd, hit enter, and I get this number. Now, if you go back and look at the first number, I'll put it on the screen here, was 7.891 times 10 to the 30th. This is 4 significant figures. We're going to divide that by Avogadro's number, and I'm just going to put this part in, and that's 3, which is a smaller number. When you multiply or divide, remember you get the same number of significant figures as the number that has the fewest. I'm going to try something I've never done before. You're the first to see this. Ooh, you can write on a spreadsheet. So, look out. Dr. White's getting dangerous. Keep this, keep this, keep this. Use this to round off. Is that 4 or less? Yes. And I take that and I cross it off. So the answer would be 1.31 times 10 to the 7. And that's how you do it. Oh, let's do another one. Practice is good for your grade. Oh, let's go to the high rent district. How many atoms of gold are 8.46 moles of gold? And remember, this will be given to you.
Dr. White, can you show your screen?
No, I can't. Thank you for letting me know. I hate Zoom when you have to switch. Now, can you see it? Can you see it now? Thank you. Thank you for letting me know. All right, let's go through this again. How many atoms of gold, AU is gold, are 8.46 moles of gold? Remember, 1 mole of an element equals 6.02 times 10 to the 23rd, Avogadro's number, atoms of the element. And have some fun. I'm going to have to record some game show music to play during this time. You know, when they ask the question, dun, 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 dun. I better not do that. I'll ruin your day. I bet I could find some on YouTube. Everything's on YouTube except I think my high school graduation. Psst, you're doing chemistry and it's not that painful. It might even be fun. And when you're done, don't forget, please give me a thumbs up. By the way, thanks to everybody for making me an international YouTube star. And when you're done, give me a thumbs up. Or if you want me to go ahead, give me a thumbs up too. All right, I think everybody's done. I see some eyes still on their paper. I'll give you another 18.7 seconds. Go. I'm looking at one of my many watches and clocks I have in front of me. I have 1, 2, 3, 4. Calendar over here. Traveling clock, my Bluetooth phone system, and a watch I keep in front. Time's up. All right, let's do it. First thing is, when you read a problem, what are you being asked to find? And the answer is, how many atoms gold? And I like to do this. You can do whatever you want to let you know. What are you given? This. And now it's time to use your good buddy, your good friend, unit analysis. You're going to have to wait until after the break for me to use my whistle again, but this is the only thing we have to start with. There's some ratio. What do I want the units of my answer to be? Well, you figure that out. Now, it's time to use your good buddy and my good buddy too, unit analysis. Whatever you're trying to get to goes on top. By the way, if you haven't figured out, red's my favorite color. And whatever units you're trying to get rid of, I don't want moles of gold in my answer, goes at the bottom. And I can do that now, and I'll write them. Now, where do we get these numbers? We come up here, and this will be given to you important information. By the way, go to look in the lecture folder of D2, nope, wrong school, Blackboard. I was about to say the ECC D2L, but we use Blackboard. And you'll see important information for test 2. In fact, hold on one second. I can't find it right now. Hold on. It was hiding from me. And everybody should see on their screen now, test 2 important information. And you can go and look at this at your leisure. This way you know what you don't have to memorize. This we've already gone through, but I'll give you this on test 2. And notice this will also be given to you. 1 mole of an element equals Avogadro's number of atoms. 1 mole of a compound equals Avogadro's number of molecules of that compound. We'll talk about that later today. 1 moles, we've already gone through this, but we'll do it again. 1 mole of an element equals the atomic weight of the element in grams, and 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights in that compound. Now, later on, I'll teach you about this, but probably, maybe not today, but probably Thursday. All right, let's go back to our problem. And so where do we get the numbers that we put in here? What ratio or relationship do we know between moles and atoms of an element? And it's right up here. 1 mole equals Avogadro's number. And that's where you get that. And you'll be given this, but you have to know where and when to use it. Now, before I move forward, I'm going to check do my units cancel out. Notice I have moles of gold divided by moles of gold. Anything divided by itself, you'll see me writing this a lot during the semester, equals 1. So these cancel out. What am I left with? Oh, look, atoms. Success, we're on the right track. Now, if this is all you did, and you didn't even put down a number, I'd give you most of the points. Because you showed me what you did, you just didn't pick up your calculator. But do pick up your calculator, because you don't want to lose these points. So, now what do? We go to our calculator. I see a question. Yes, atomic weights and atomic masses are the same thing. If you want, certain chemists would get into an intense argument with me that the right name is only atomic mass, because that's independent of gravity. However, since I think I established the first day of class, none of us are leaving the planet Earth before the end of the semester. Well, tell me if you are, I'd like to come along. But anyways, if you're not, then you can also use atomic weight interchangeably, and I do. Same thing with molecular mass, molecular weight. I use those interchangeably. Now, hopefully you all see my spreadsheet up here. You see it? Okay. And now let's get rid of this. Yeah. And we want to take 8.46 times Avogadro's number, 6.02, times 10 to the 23rd. Remember, on your calculator, you press, for those who have most like I do, you press the second key, blue, and then the double E, and that's how you then put in a number for the power. Hit the enter. Yeah. Something Dr. White always forgets to do in a spreadsheet, put the plus sign, hit the enter. Here we have our number. Now, the first number was 8.46. Forget about the zeros. This is 3 significant figures. This is 6.02. And therefore, round this off to 3 significant figures. I'll let you do it first, and then I'll do it. And the answer is keep the 5, keep the 0, keep the 9. Use the 2 to round off. Is that 4 or less? Yes. So I drop all this, and it's 5.09 times 10 to the 24th. And therefore, and that's how you do it. Now, a good thing why you should show your work. What if you press the wrong button and for some reason you put down, say, this. You pushed a lot of wrong buttons. Well, that's wrong. But if you showed me all this, and this is a 5 or 6 point problem, I'd look at this and say, math error, -1, as opposed to getting 0. So it always pays to show your work. We skipped this. We talked about molecular mass and elemental molar mass, which Dr. White will use molecular weight and the atomic weight. Good habits I don't change. Again, for molecular molar mass, you'll see me do molecular weight. And again, the atomic weight for this class is the atomic mass of the element in grams. And the molecular weight is the formula weight, or the molecular weight is the sum of the molecular weight, which another way of saying this is sum of all sum of all atomic weights in a molecule. And if I look at my clock, it says it's time for a break. And so let's take a break, come back in 5. I'm going to do my stretching exercises, especially after all the exercise I got this weekend, moving and cutting branches. I'll show you pictures on Thursday. Take 5. Come back, please. All right, let me get you all back. Time to start again. Another whistle I have. All right, let's get going again. And where do we leave off? Now we were talking about molar mass, also known as either atomic weight in grams or molecular weight in grams. Now, it turns out you can use other units. The same thing applies if you use pounds or kilograms, which Dr. White has, but for this class, I won't. Now, this is very important. Probably one of the most important things I know in all of chemistry, and that is 1 mole of an element equals its atomic mass or weight in grams. 1 mole of an element equals its atomic weight in grams. And 1 mole of a compound equals its the reason I have this on the slide, that's what's in your book, but hopefully nobody bought the book. Well, I'll be quiet. Shh. 1 mole of a compound equals its molecular weight in grams. Remember, the molecular weight let's try this again. The molecular weight is the sum of all atomic weights in a compound. This will be given to you in test number 2, important information. And let me prove to you I'm not lying. And notice this will be at the end of the test. 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights in that compound. And like I said, in the past, I'd have students memorize this along with knowing how to use this. Now I'm just asking you to know how to use this. Staying in the high rent district, question is 6 points, maybe more. How many grams silver is 15.23 moles of silver? So let's look at what are we being asked to find? How many grams of silver? What are we given? This. And now we also know from important information 1 mole of an element equals its atomic weight, and I'll be abbreviating. This is the abbreviation for atomic weight. Dr. White tell you organic chemists are lazy. Whenever we can abbreviate, we do. I won't do that on a test, but now I can because Dr. White's lazy. So how do we proceed? Well, there's only one number we have to work with. And what units do I want my answer to be in? Grams of silver. And now it's time to use your good buddy, your good friend, unit analysis, and has been my good buddy, whatever units you're trying to get to. Whoa, come on back, red pen. There we go. Whatever units we're trying to get to goes on top of the ratio. Whatever units we're trying to get rid of go underneath. And here we want grams of silver. And here we want moles of silver. Where do we get these numbers? From this, 1 mole of an element equals the atomic weight of the element, and I should have put in here in grams. And where do we get that? We go to our local friendly neighborhood periodic table. And now you look for atomic weight of silver. Now, remember on test 2, it will say in 3, 4 in the final, please use all atomic weights to 3 significant figures. I'll let you round that off to 3 significant figures first. Time's up. Keep the 1, keep the 0, keep the 7. Use the 0.8 or the 8 to round off. Is that 4 or less, 5 or higher? Time's up, 5 or higher. So I drop all that, increase this to 1. The atomic weight in grams of 1 mole of silver is 108 grams. So now I can go back and say, this is 108 grams. And now, before I pick up my calculator, or in my case, go to my spreadsheet, notice moles divided by moles of silver cancel out, become the number 1. I'm left with grams of silver, so I'm on the right track. So that means I can go to my calculator and now everybody see the calculator, the spreadsheet on there? Thank you. All right, why don't you want to? Hold on. For whatever reason, my calculator was playing games with me. Oh, we got it. If I take it and look at what I have 15.23 times 108. And here's the number I get. Now this one's interesting, but let's do it. Now, the first number we multiplied was 15.23, which is 4 significant figures. The next number was 108, which is 3 significant figures. So now you have to round this off to 3 significant figures. I'll let you try that. All right, my turn. Keep the 1, keep the 6, keep the 4. Notice this is the one to round off is 4 or less. Therefore, I would delete that and that. So it'd be 1,640. Now, if you had your calculator set to scientific notation, which either way works for me because I know both. And notice here, you'd round that off to 1.64 times 10 to the third, which is same as 1,640. Which number is correct? Either one. So either one is the correct answer. And let me let you try this one. How many grams of platinum are 8.63 moles of platinum? Now, in case you don't have your periodic table in there, here's platinum. I'll help you out. First, you try it. Round that off to 3 significant figures. And times up 195. And here, I won't give this to you on a test, but today I will. This is a way of saying it's these many grams for 1 mole, or this is just the atomic weight in grams, 195. And why don't you try it? And remember, up here, you'll be given this information. 1 mole of an element equals the atomic weight of that element in grams. Don't forget, you can catch me on YouTube anytime you want to, and you have internet access, because best I know, YouTube is 24/7. And by the end of today, probably by the end of the afternoon, I will be posting this video. By the way, right after class today, Dr. White has it's that time of the year again to add some more water to my water bed. I've had a water bed since, well, 1978. Not the same one, but if you've never slept in a water bed, you're missing a lot. All right, when you're done, give me a thumbs up, especially those of you who don't have your video on or don't have a video to turn on. Thank you. Looks like everybody's done. Let's do this. All right, how do you proceed? The first thing you do is ask, what are you being asked to find? How many grams of platinum? Next, what are you given? How many moles of platinum do you have? And now there's only one number we have to start with. If I had a ratio, what would I want that I multiplied or converted this to? What do I want my units, my final answer? Well, we figured that out. Grams of platinum. And now it's time to use your good buddy, your good friend. I'm not going to overdose you with the siren whistle, so I won't. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. I can do that. And now put the units I want on top, grams of platinum. What do I want to get rid of goes underneath, moles of platinum. And where do I get these two numbers? I look up here, or you look at important information. 1 mole of an element equals the atomic weight of the element in grams. That's not too hard. And you look on the periodic table and you'd find that the atomic weight of platinum is that, and 1 mole equals 195 grams of platinum. And don't forget, 1 is an exact number. And now, before I pick up my calculator, I'll look at, do my units cancel out? And notice here, we have moles of platinum divided by moles of platinum. Anything divided by itself equals the number 1, cancels out. So this cancels out. What am I left with? Yay, grams of platinum. I'm on the right track. So now I can go to my calculator. A 0.63 times 195. Now, before I hit enter, how many significant figures? 8.63? 3. How many is 195? 3. So my answer should have 3 significant figures. And I had it in scientific notation, which most of you will. Round that off to 3 significant figures. Time's up. Keep the 1, keep the 6, keep the 8. Use the 2 to round off. That's 4 or less, so it's 1.68 times 10 to the third. Grams of platinum. Do I have time? I think I do. Did I talk about the platinum ring in a student of mine in this class yet? All right, time for Dr. White's story. A number of years ago, I was teaching this course at another school. It's called Chem 112 at Elgin Community College. And one of my students, she came in and said, "Look, Dr. White, I just got engaged." And she showed the whole class, and it was a beautiful ring. And it was platinum. And it had a beautiful diamond on top. No, this isn't a diamond. But anyways, a couple weeks later, she comes to me and says, "Can you help me out? I'm quite upset about something." I said, "What?" She said, "Look at the bottom of my ring here. It's all scratched up and dented." And I said, "What is it made out of?" Because I didn't ask her. I didn't know if it was white gold or something else. And she said, "Platinum." I said, "Oh, by the way, the physical property of platinum is it's a soft metal. It's not hard like gold. If you notice this ring, you don't see any scratches on there. It's worn a little, but not. And I hate this. I've had this ring since 1972. And now you know gold has much better physical properties than platinum, for rings at least. I don't know, what's the price of platinum and gold nowadays? Hold on. Do I have time? Yeah, I do. All right, price of gold is roughly $1,900 per ounce. And platinum is only $910 per ounce. So to all of you who are thinking, give me gold instead of platinum for my birthday. Actually, I really want a mold of pennies. All right, let's get back to work. Now, the other thing which we have in practice is 1 mole of a compound equals its molecular weight in grams. 1 mole of a compound equals its molecular weight in in grams. I was getting ahead of myself. In the past, I would tell the class, don't forget to memorize this. You need to know this. Hint. Now I'm telling you, know how to use this, because this will be an important information. So let's look at how we use this. And don't forget, the molecular weight is the sum of all atomic weights. And let's look at one. And let me just confirm. Everybody see my whiteboard where it says how many grams? Thank you. All right, I'll do this one. You know I'm going to share. So the question is, how many grams of ammonia are 2.117 times 10 to the third moles of ammonia? So what are we trying to find? Grams of ammonia. What are we given? 2.117 moles of ammonia. What else do you know? Well, before we do that, let's use our good buddy, our good friend, unit analysis. What do we have to start with? Only this number. If we had some ratio, we could multiply this. What answer do we want to get? Grams of ammonia. NH3 is ammonia. And what do we do now? Oh, I got to do it once more. I got to. Use your good buddy, your good friend. Unit analysis. And whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. I can do that. I want on top grams of ammonia. I want underneath moles of ammonia. And where do we get that? If you look at important information, you'll see 1 mole compound equals, and I'm going to use abbreviation, MW is molecular weight in grams of the compound. And the molecular weight equals the sum of all atomic weights. That will be given to you, not in abbreviated form, but in important information at test number 2. Oh no, Dr. White was cruel. He didn't give us the molecular weight of ammonia. Well, how do you do that? Well, the molecular weight of ammonia, you have to calculate it. That's why this is more points, this is more work, is the sum of all atomic weights. I have 3 hydrogens, I have 1 nitrogen, 3. If you look up the atomic weight of hydrogen, it's 1.01. Look up the atomic weight of nitrogen is 14.0. Do the math. Remember, 1 and 3 are exact numbers. One significant, 2, round this off. So it's 17.0. And I know 1 mole of a compound equals its molecular weight, which is the sum of all atomic weights in grams. And now I have this. Now, before I move forward, I'm going to check, do my units cancel out? Notice I have moles of ammonia divided by moles of ammonia. Remember, anything divided by itself equals number 1, which means it cancels out. And therefore, this cancels out. What am I left with? Yay, grams of ammonia. I'm on the right track. And now I feel confident if I go to my calculator, I will get the right number. So let's do it. .11, whoa, 117 times 10 to the third times 17.0. And this is a number I get. Whoa! If you notice, the 2 numbers we were multiplying were 2.117 and 17.0. Notice this is 4 significant figures, 3 significant figures. What should my answer be? When you do a multiplication or division, you should get the same number of significant figures as the number with the lowest significant figures, which is 3. I'll let you round this off to 3 significant figures. This is an interesting one to do. Time's up. Let's look at this. We keep the 3. We keep the 5. We keep the 9. Those are my 3 significant figures. Use 8 to round off. 8 and everything else I drop. And this is 5 or higher. So this number increases to 1 by 1, which is increasing 59 to 60. So this would be 3.60 times 10 to the 4th. So if you need these many moles of ammonia, you go in the lab and weigh out this many grams of ammonia. I'll say that again. If you need these many moles of ammonia, you weigh out, because you can't measure molecules. At least I can't count them unless you're Superman or Superwoman, or was it Supergirl? One of the two or three. Unless you have X-ray vision or microscopic vision, I don't know which one, I and you can count molecules, but we can go to balance and weigh out something. And I've worked with ammonia and I've weighed out ammonia to use in reactions. So that's how you do it. I haven't asked this in a while. Any questions so far? Don't forget, my class is always going to be true, and in my office hour and anywhere in my life, there's no such thing as a dumb question. Always feel free to ask questions. It's a good thing. All right, time for me to share. And the question is, how many grams water are 8.88 times 10 to the third moles of water? Just in case you need it. The atomic weights of oxygen and hydrogen are those. And if you don't have a calculator, just set it up and get to work. At this point, Dr. White would be looking around the class to see all the students working and make my heart feel so good. By the way, it's good to make your heart feel good. Always be nice to yourself. That's a good thing to go through life, because it's too easy to beat up on yourself. And it's good to see everybody hard at work doing their moles and grams problem. I'll be quiet. Don't look, don't look. All right, anybody need more time? If not, give me a thumbs up. I'll tell you what, I'll give you another minute and then I'm going to do it. For those of you who finished early, try going this, one forward, one backward at the same time. And then when you finish that, do it with your thumbs, one forward, one back. My father challenged me when I was about 5 or 6. He always used to tell me a smart person is never bored. By the way, don't do that while you're driving or operating heavy machinery, please. All right, let's do this. All right, here's a problem. How many grams water are in 8.88 times 10 to the third moles of water? What are we being asked to find? Grams of water. What are we given? Moles of water. Oops. And if you forget to do that, and I see that on a problem, you lose 1 point. Copy error, or just math error, I'd call it, being polite. And now, what do you do? Well, you get some more space, and you say, this is the only number I have to start with. And what am I trying to get to units-wise? Grams of water. And now it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And now I have moles of water. Up here I have grams of water. And where do I get those numbers? Important information. One mole of a compound equals its molecular weight in grams, and the molecular weight equals the sum of all atomic weights. And therefore, oh, he didn't give it to us. We got to figure out what's the molecular weight of water. And we've done this, I'll do this quick. 2 hydrogen, 1 oxygen, you add this and you get 18.02, 2 past the decimal, 1, round this off to 1 past the decimal, 18.0, 1 mole of water is 18.0 grams. Now, before I pick up my calculator, I'm going to look at the units. Remember, moles of water divided by moles of water, anything divided by itself equals number 1, which means it cancels out. I'm left with grams of water. Yay, I'm on the right track. And now I know I can pick up my calculator and go to it. Notice 8.88 and 18.03 significant figures. Here's the number I have. You round that off to 3 significant figures. Here's another hard one. You try it and then I'll do it. And the answer is 1.60 times 10 to the 5th. And notice this, I thought we got a similar number. Well, whatever. But anyways, here, keep the 1, keep the 5, keep the 9, use the 8 to round off. That's 5 or higher, drop all that, change 59 to 60. I think we got something similar before. Wow, that's spooky. And if we look here, we get 1.60 times 10 to the 5th gram. So if I ever ask you, quick, I need 8.88 times 10 to the 3rd moles of water, well, you weigh out these many grams of water. By the way, I've done calculations like this dealing with pounds, where you're dealing up to, I've dealt up to, oh, close to 250,000 pounds. That's a lot of money, somebody else's, and you don't want to ever make mistakes here. Let's try one more. And why don't you try this one? And just to help you out, we already did the molecular weight of water is 18.0. And don't forget, 1 mole of a compound equals its molecular weight. You try. How many moles of water are 567 grams of water? Get moving. We're almost done today, so hurry up. Or as Germans say, mach schnell, which means make fast. Dr. White worked a lot in Germany in the late 80s, early 90s, so my German's rusty now, but back then it wasn't too bad. I also took German in high school and college. Remember, use your good buddy, your good friend, unit analysis. Don't forget, hand in your lab that we did last week, by this Thursday, end of the day. I think Dr. White's going to sneeze, so hang in there. Oh, I stifled it. Warning, I'm going to go about 120 seconds over the end. So don't get too mad at me. If you're done, give me a thumbs up. If you're not, don't. That's profound. All right, let's get going. What are we being asked to find? How many moles of water? What are we given? How many grams of water? Time to use unit analysis. Your good buddy, your good friend. Remember, I'm going for the Guinness Book of World Record, saying that the most in one semester. This is what we have to start with. What units do we want our answer in? Moles of water. And now use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. A little different from last problem, but really similar. And now where do I get these numbers? 1 mole equals the molecular weight in grams of a compound. And for water, the molecular weight is 18. So 1 mole of water is 18.0 grams. Now, before I pick up my calculator, I'm going to say that my units cancel out. We have grams of water divided by grams of water. Anything divided by itself equals the number 1. Therefore, this cancels out. I'm left with moles of water. Yay, I'm doing it right. And now it's time to go to my calculator. Ooh, I'm going almost 3 minutes over. I apologize. And I get, let's do one thing. $31.500, three significant figures, 31.5. And that's how many moles. And that's how you do it. Today I gave you a real workout in unit analysis. Thank you for sticking with me. It's time for me to say goodbye, gehen gesund, be healthy. For those of you who got an extra 30 seconds, I was just thinking, I will not, from one of my favorite shows when I was a kid, they were younger before this was taken, Roy Rogers' show. Every show they'd end up singing Happy Trails to you until we meet again. I'm not going to sing the rest of it. I'll ruin it for you. With that, bye. Gehen gesund. Be healthy. I'll see you on Thursday.